ladies and gentlemen. All right, so we have 96 Tech Sid block. This is the original block that was in the car. We had the cylinders bored out to 357. Yeah, so it's very clean block. Machine work is really well done. It's beautiful. We are going to triple check all the clearances and everything to make sure everything's good. So I'll do a quick rundown of the process of what's going on now. When you have a block at the machine shop and you get it back, never assume that it is clean, because the machine shop has a lot of metal flying around, a lot of things happening, a lot of metal powder, and you want to keep it safe. So the thing to do is wash it really good with soap and water and high pressured water. That's pretty much it. I didn't use soap on this because I didn't really need to. There was no grease on it that I needed to worry about. And the process to do that is I have a pressure washer, so I just nail it with the pressure washer. You spray in all these holes. You spray in the oil galleys or oil channels, you know, which are these here where the oil drains down. I spray the heck out of the cylinders, you know, just a general wash of the whole thing. Spray on the inside, spray up underneath it. Make sure you get everything, right? You want to hit all the holes, all the crevices. I mean, I'm spraying in here. Just hit the whole thing through. And then once it's done, I use a leaf blower, actually, and I blow it off with a leaf blower as dry as I can get it. That actually works pretty good. It's a gas-powered leaf blower. And then I use my air compressor to blow out all the little holes and get all the oil or all the water out of all those spaces. This is an aluminum block, so I am really not concerned with anything that is not the cylinder walls and your mains, because nothing else is going to rust. It's aluminum, so it can't. And then once you have that done, what do you do to keep it from rusting? Because rust pops up real quick on, you know, perfectly clean metals. And what I do is I use WD-40. The WD in WD-40 is actually for water displacement. So it'll actually push the water off and won't let water touch the surface. So you can see how clean all this stuff is. And I literally sprayed it with a water hose. I mean, I soaked it. So once it's done, you blow it off, blow all the air off of it. I don't even wipe it down, because if you wipe it down, you risk getting, you know, fuzz and lint and stuff everywhere. So once it's sprayed down with air and pretty much completely dry from blowing it off with air, I then spritz everything with the WD-40, and it displaces the water, no rust. It could literally sit here for months. I would put a plastic bag over it and it would never corrode with that WD-40 on it. Every now and then I pull the bag off, maybe wipe it down, spray it again. And again, if it sits for a while, you always want to wash it again before you do any sort of engine assembly. And then as I do the engine assembly, I clean everything as I go. So it's a very big deal. So what we're going to do today, that's the old Mystic engine that was in my car with the new trigger wheel. Looks like it's going to be fine. Sorry, this is my special measuring tools. So this is this tool right here. This is a nice one. So what this is it actually centers the ring in the cylinder, right? And what we're going to do is we're going to take the rings. You got your top rings here and you got your secondary ring. You don't really do it with the oil rings. You obviously don't file these. That's another thing. So we're going to file these rings and these rings. We're going to do our measurement to see which, you know, what the gap's going to be. And then we're going to take each ring and you put the ring inside the cylinder, okay? And then you take your tool and you put it in there. A lot of people have this idea of, you know, taking a piston, putting a ring on the piston, and upside down putting the piston into the cylinder to center the ring. What you want is the ring to be perfectly 90 degrees inside the cylinder wall, so that way the measurement is exactly straight and perfect. And the reason I don't like using a piston is because you're basically using one of your rings that you're going to use for assembly to be, you know, what you're using as a tool, and that's not something I'm down for. And you're using a piston that you're going to be putting in the assembly as a tool. So I'd rather have an actual tool that's designed for it. It brings the ring down exactly where it needs to be. It's a window of, you know, 3550 to 3650, which is in our 3572 range. Looks good. So we'll put a ring at the surface and then we'll push it down with this, and that'll square it away. And then we take that off and we can take our measurement. I'll do a time-lapse video of doing the whole ring cut, so you can watch it. And it's a tedious process, but once it's done, that literally will save the entire engine. And you do the ring cut, the gap, based on what the engine's going to be doing, supercharger, nitrous, and et cetera, et cetera. Walk you through what parts we got here. So Tech Sid engine block. We have our total seal engine or compression rings, C-clips for the pistons. We've got our rings for the oil. This is our piston ring compressor. I got a new one for this size bore, 3572. I really like this design. It's just so much better than using your conventional kind of like grip type. For high dollar engine builds, I always make sure I have the right one of those. Thank you, Isaac, by the way, for actually ordering that for me. This is his engine build. We've got our tool for the setting the rings down. We have our pistons, which are some nice manly pistons. We got the grooves cut in for the exhaust valves. And here's a hot tip. If a piston to valve clearance ever is an issue, if it's not a timing issue, I would say 99 out of 100 times it's going to be the exhaust valve. And the reason being is because the exhaust valve is the only thing that the piston is chasing back up into the cylinder head. So if a valve floats, it's going to touch the exhaust valve. It'll never touch the intake valve on float. Or an over rev situation. So we got all of our pistons. And again, so what I'm going to do is I'm going to measure a ring, right? Once I measure the ring, I'm going to take it out. I'm going to number the table 1 through 8. And that ring will sit on 1, 2, whatever, 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8, yeah. And I'll measure or number each one. So whatever the bore is going to be what the ring was cut for, and it'll be per cylinder. And then I'll have each piston, matched with its rod and numbered as well. These are our rods. This is a brand new set of rods. And these are our new rod bolts that we're going to use. And then we have our male, which is actually the correct way to pronounce that, male. Rod bearings. These are 20 thousandths over because we actually had to do work to the crank. That was a whole thing that got delayed on the project. And then we have our main bearings, which are 10 thousandths over. Oversized for the extra clearance on the crank. The crank had to be worked really, really hard. So they actually took material off of where the rod journals are, and they actually took material off where the mains are. So this crank should be really squared away and good to go. These are rod bearings that are stock size, and so we're not going to use these, so that's an extra set now. And then this is our head bolts, which we're not going to move on to the heads just yet. We got some things that we need to do to make sure the heads are perfect. One of those things is degreeing in the cams, so that's going to be a whole other process to the thing. But yeah, long story short, this is our next thing. The next step is cutting these rings, marrying the pistons with the rods, putting our rod bolts, with that, have our rod bearings ready to go. Have all the clearances and everything measured with really, really high-end good tools. Make sure everything is absolutely perfect. We're going to have our engine assembly lube, and then we'll put our mains in, and then we'll put the crankshaft in to the block. And then once that's in, we'll have our rings and pistons and rods all assembled, laid out here pretty on the table. And then we'll take them one by one and put them into the block. And then that's going to assemble our short block. So hopefully in the next day or two, you have that video to check out. So appreciate you guys. If you got any questions, drop it in the comments. I'm hoping to, I don't know. I'm hoping for a lot of things, but we'll see what I do with the YouTube and everything else. I don't know, man. I'm just trying to get life done. So we'll get to it. I love you guys. Talk to you later. I actually forgot to show you this. This is our simple ring filer. It's a pretty interesting tool to use, but it works freaking great. And I've cut a lot of rings with it. And once you get the technique of how to hold the ring up and keep it exactly square on the tool, you can get a lot done. So the way to make sure it's square is you squeeze the ring together, and that ring gap needs to be perfectly straight and touch all the way up and down. And so that's the tool we're going to use.